So we're going to review some of the pre-calculus skills. It is really important that we are very fluent and really know our pre-calculus skills because many of them are kind of embedded in a lot of the calculus that we're going to do. So one of them is function notation and how we deal with function notation. So the function notation, when we have f of the sum expression here, we first of all define our f function. Okay, so here's our f function defined. Here's our g function defined. And depending on the function that we're using, we're just going to embed the variable or the number in for where the x is. So f of -2 is going to be equal to the square root of 3. We substitute the -2 in and evaluate that expression. So in this case here, we're going to end up with -6 minus 2. So that ends up being -8. Okay, and this is an imaginary number, so we can't actually work this out. So this does not exist. Okay, so for b, we're now defining the g function. And in this case here, we can substitute not just numbers, but we can also substitute expressions in for the variable. So here we're going to define the g function as 2x squared plus 1. So this function notation is going to mean this. We have our function 2x squared plus 1. And inside that, we are going to embed the 3x plus 1 into that function. Okay, so once we've done that, we've actually done the function notation. What's implied though, we should always expand and simplify or combine like terms. So here we're going to end up with 2 times 9x squared plus 6x plus 1 plus 1. So 18x squared plus 12x plus 2 plus 1, so plus 3. So we can also combine functions using function notation. So f of x minus f of g just means we're going to take our f of x function. Yeah, I'll do this one in red. So we're going to take our f of x function, 3x minus 2, and then we're going to subtract our g function. Okay, so it just becomes 2x squared plus 1. Well, there's something wrong with what I've done here. And in this case here, since I'm subtracting, this is in particular when we have subtraction, I'm subtracting the g. That means I need to subtract the whole thing. So I need to subtract all of this. So I'm going to subtract the plus 1. If I leave the brackets out, okay, that means I'm actually adding 1 instead of subtracting 1. And this notation shows up as well, where we have the f minus g of x. That means that f of x minus g of x, these are the same thing. The last one here is we can embed a function notation inside another function notation. So what that means then is if we have the outside function is f, that's going to be on the outside. The inside function is g, so then wherever we have the x, we're going to embed our g function. Okay, so the g function is defined as 2x squared plus 1, so we're going to embed the 2x squared plus 1 function inside the g function. Or sorry, the g function inside the f function here like this. Okay, and then we should simplify by combining like terms. So we get 6x squared plus 3 minus 2, which is plus 1. Okay, so there we go. So domain and range. We want to make sure we understand domain and range, and this issue of continuous and discrete shows up in these two graphs. So in this case here, this is a discrete function, the first one a. So we have our domain is going to be 1, 3, 4, and 6. And when we have discrete functions, it's actually easier maybe to list out the actual domain. So we can list it out as domain is, actually I should do it like this properly. So X, okay, that's our variable, and it's going to be 1, 3, 4, and 6. Okay, so we can list out discrete functions like this in our domain. For the y, we can list it out the same, discrete functions. We're just using our function or domain and range notation here. So y can be from -1, okay, 2, and 5. Okay, so we can list out our domain and range of discrete pieces in this way. Now, sometimes we can list it out in terms of expressing this as integers. If we have consecutive integers, that might be an easier way to do it. When we have these discrete functions, we can actually count them up. It's probably easiest just to actually list them all out. So this one is this is a discrete function. Okay, the one on the right here is a continuous function. Okay, so this one's continuous. So we need to be able to express all these x variables, all these continuous x variables. So we can't just list them out because there's infinite numbers of them. So when we talk about the domain, okay, we're going to say x, and we can just say that the domain is going to be from, it starts at -5. Okay, we're going to include -5 as part of our domain, and it's going to go all the way to +5, but not including +5. Okay, and we should say it's XER, although if we don't put the XER, it's implied that it's all real numbers. Okay, so that's our kind of interval notation, or sorry, our domain notation. We also in AP Calculus is going to switch over to different notation. When we have an interval like this, we're going to write our interval this way. So -5. Okay, the square brackets indicates that we're going to include the -5 as part of our domain. And the round brackets on the other side means that we're going to not include 5 as part of our domain. So this is what we call a half open interval. So it's closed on this side with -5 and it's open on the side of +5. Okay, so just so that I'm going to just highlight this so that you're clear. That equal to relates to that, and this not equal to relates to the curve bracket. Okay, so then the range of this is going to be, if I use our regular notation, it's going to be from 0, and I'm going to include 0 as part of my range. Okay, and it's going to go all the way up to, looks like +6. Okay, and it does not include 6, so we leave that open like that, and then this is continuous, so we should write YER. And again, it's usually implied, so usually you don't need to write that, but we just for completeness, we're going to write that. And in our interval notation, we're going to write it like this. Okay, so that's a closed interval, and this side is what we call open. Okay, so and again, just going to highlight that. The equal to means we use that square bracket. The not equal to means we're going to use the round bracket as part of our interval notation.